Recall from our work with trapezoids in the last unit that we had a vocabulary term towards the end of the unit called the midsegment of a trapezoid. And recall that the midsegment of a trapezoid, if we remember that, let's see here, we had, let's say this is a trapezoid here. The midsegment of a trapezoid connected the midpoints of the legs of the trapezoid. So there's a midpoint here and a midpoint here, and that was the midsegment. So we have a similar idea with triangles in which we have something called a midsegment, but there are actually three midsegments in a triangle. So a midsegment just connects the midpoints of two sides at a time of a triangle. So a midsegment of a triangle is a segment with endpoints that are the midpoints of two sides of the triangle. Every triangle, therefore, has three midsegments because it has three sides. And you'll notice that in triangle ABC over to the right here, that we have three midsegments, RP, PQ, and RQ. Now, once we have those midsegments drawn in, we have some relationships that are true. So a midsegment of a triangle is going to be parallel to one side of the triangle. So if this, then we have the midsegment that is going to be parallel to one side of the triangle, and also is going to be 1/2 the length of that third side. So I'm just going to refer to one of these midsegments. I'm going to refer to RP and how it compares to that segment CB. And so we notice that the midsegment is parallel to that side, and that would be true for PQ as it corresponds with AC, and also midsegment RQ as it corresponds with segment AB. And we also have a side relationship there, or a length relationship, maybe would be the better way to say it. So if this midsegment RP here is length 3, then that means that the entire segment, which is the side of the triangle that it is parallel to, would be of length 6. So there's always that 2-to-1 ratio that the midsegment is half of that third side. And again, that would be true for all of the midsegments in this triangle. I just outlined the RP midsegment to the BC segment. Okay, so let's go through and just apply that theorem with another example or two. I'm going to switch back to my St. Patrick's Day green. I know you guys might not be seeing this on St. Patrick's Day, but I am recording it on St. Patrick's Day, so we're going to stick with our green theme here. All right, so let's see what we've got. We're being told that XY is a midsegment and XZ is a midsegment. So if XY is a midsegment, it doesn't really look like this is drawn to scale though, does it? But we are told that XY is a midsegment, so that means that these two parts are congruent because Y must be the midpoint. And we're also told that XZ is a midsegment, and therefore Z is the midpoint, so we're going to draw that in. And we're also given some angles and length relationships. One of the things that is being asked for us here is to find length XZ. So we're going to find this length here. All right, so as we talked about earlier, the midsegment is going to be half the length of that third side. So XZ is going to be equal to 1/2 of 13, since 13 is that third side RT. And so that would be 6.5, 6.5. Great. Let's also find ST. So let's go ahead and use ST here. So we're looking at this length right here, ST. And looking at that, we have a mid-segment here that is 7, and then ST would therefore be 2 times that length. So ST is going to be equal to 2 times the mid-segment length. So 2 times 7 is 14. In our last example here, we are going to be looking at an angle measure, and we're being asked to find the angle measure RYX. So RYX would be this angle right here. All right, now notice what we have here is that the mid-segment, recall, had that length relationship, but it also has that relationship in which it is parallel to the third side. So we know that XZ is parallel to RT. And from our work earlier in the year, recall that when we have parallel lines intersect by a transversal line, that alternate interior angles will be congruent to each other. So our measure of RYX is going to be equal to, or congruent to, the measure of angle YXZ, which is equal to 124 degrees. So 124 degrees for that angle right there. And again, we know that because it is an alternate interior angle.